session is on the study of a liquid element, bromine. If you viewed two of the previous tapes on elements, we had two on a solid element, copper. So let's start. Here's how we start learning about an element. I hope you know by now it starts with observation. Observation. Using the senses, being quantitative, varying your perspective, extending your vision with, or your observations with instruments, imposing change, no value judgments. Well, we have a problem with bromine. That's why I picked it. Because if we use our senses, we're going to find out that we can't touch it because it destroys tissue, bromine. We can't smell it because 0.1% is toxic, it's fatal. We can't taste it because it's poison. So we have some real problems. We can listen to it, and if we hold our ear up to it, we can find out, we could say it has no apparent sound. So vision is about the main sense that we're going to use. And in fact, if you look at bromine, you'll notice the first thing about it is a liquid. It is in a, you could say, it's in a closed container. It appears to be closed. We can say, and this is one of the main things, it's a dark red-brown color. And you'll notice there's some, and again, however you would describe it, like an elementary child, you could say there's a light red-brown, you could call it fumes if you wish, a gas above it, vapor above the liquid. You can't do much more than that. You can't. So one of the first things we have to talk about is, before we go into it, is a little bit of the background, the history of the element. The element was discovered in about 1825. And if you look on this periodic chart, you'll notice that it is one of two liquid elements at room temperature. The other liquid element is mercury. So we didn't have much choice on the liquid elements. You would see that it's in a group of elements called group 7A in the periodic chart. It's called the halogens. And all these elements are very similar. Fluorine, chlorine, bromine, and iodine. They have some similar characteristics. They all form what they call salts, and we'll be talking about that later. The production, it comes from seawater, and the production is in the neighborhood of something like 600,000 metric tons per year. Now, a metric ton, that is a metric ton is 1,000 kilograms. And if you want to know how many pounds that is, you should use dimension analysis. You put what you want to get rid of in the denominator, it's gone, and put pounds in the numerator, what you want. And 1 kilogram, This is something you need, especially if you go to Europe. 1 kilogram, and I'll switch the color here. 1 kilogram is 2.2 pounds. So you can see a metric ton is equal to about 2,200 pounds, whereas our English ton is 2,000 pounds. So, what do we learn about this thing? First of all, let's look at the density. The density. Well, if you go over to this chart on density, you'll see that it's about 3.1, is it? 3.1 grams per cubic centimeter. Now, you could say, well, what does that mean? Well, we could look at comparative densities, but 3.1 grams, you can think of water as 1 gram per cubic centimeter. Did you hear that? Water is 1 gram per cubic centimeter. So it's about 3 times the density of liquid water. So it's a dense liquid. The next thing we can do is look at the boiling points. Boiling point. Now, bromine boils, if you look over in the far right side, group 7A, boils at about 58.77. It boils at about 59 degrees Celsius. So that's why it looks very colorful above the liquid, because it's vaporizing to a great extent already. And if you look at this chart that we put up here, you'll see that it vaporizes and the chart stops at about 59 degrees Celsius. That's when it's completely vapored, turned to vapor 100%. And it stops at -7 degrees Celsius, and that's when it freezes. So it has a very narrow range from -7 to 59 degrees, where it goes from a solid to a liquid to a gas. And that's called a phase change. The chart that I put up next, if you go over to bromine, you will see what I said, that bromine freezes at -7 degrees Celsius. Well, that's just a preliminary view of bromine. And again, I'm not going to say the word as many times now, but we looked at the patterns of the elements, and we saw trends, and we learned from looking at the relationship of our elements to all the other elements in the periodic chart. We will stop there.